Several brilliant artworks have come from Henri Matisse and Paul Cézanne, thanks to the curious European minds of the 1800s. With great veneration, those European minds concocted colorful new hues and dyes with the purpose to signify a distinction in chromosomes. This repurposing method scientists used for analyzing specific chromosomal aspects was later used by scientists to examine the cycles of divisible cells and to see the process in which chromosomes were transported. Along with Cubism and Dadaism, abstract art grew very popular in the world of fine arts. One type of art in particular is bio-art, invented by Edward J. Steichen, an American photographer and curator. Although Steichen was a photographer, he enjoyed spending time in his garden, where he once experimented with his delphinium seeds by mixing them with his medication. By doing this, Steichen doubled the amount of chromosomes in the herbal species, and some resulted in prodigious-sized flora. Steichen later displayed 500 delphiniums at the Museum of Modern Art in New York. James Watson and Francis Crick are best known for their accomplishments in comprehending the once believed incomprehensible blueprints of deoxyribonucleic acid. Watson and Crick can best be compared to any well-known artist or sculptor who took pride in their work, due to the tedious work they had put into their DNA model. Watson and Crick made several different types of models on DNA, mostly from cardboard or tin, but they concluded with the double helix model due to its elegant qualities. Although several complications arose as to how DNA copied itself, the solution was that proteins act as a minuscule biological welder, snipping sequences of DNA and soldering those sequences back later. For example, in the modern world, where examples of genetic engineering can be found almost anywhere, those organisms have more than likely been altered by some type of genetic modification tool. In particular, the greatest controllable genetic modification tool that we know of today is CRISPR-Cas9. And the Cas9 in CRISPR is a protein that snips away sequences of DNA and replaces them with different sequences in its place. The quest for the boss gene for language sounds like an admirable journey, but consequently, scientists have only concluded with a gene called FOXP2 from a boy unrelated to the original Keys family in London. In previous years, scientists studied about 3 generations of the Keys family in hopes of finding a major gene correlated with language. After scientists had discovered the FOXP2 gene in 1996, they experimented on mice with the gene and found that the now mutant mice squeaked in a much lower tone than before. Sergei Rachmaninoff was a very gifted pianist in that his enormous hands made him more adept in the range of notes he could play in a given piece of music. Rachmaninoff's hands were so large due to Marfan syndrome, a genetic disorder that affects the eyes, heart, blood vessels, bones, and connective tissue. Rachmaninoff's dexterous capabilities on the piano proved to be a positive aspect of his extremely large hands. Unfortunately, focal dystonia made Robert Schumann's middle finger move in an uncontrollable way, which greatly impacted his occupation. Schumann's dream of being an active concert pianist was only set to be flawed by focal dystonia and forever ceased his job as a concert pianist. Gioacchino Rossini was an Italian composer most known for his operas like Cinderella, Semiramide, and The Barber of Seville. During one of Niccolo Paganini's performances, Rossini admitted to publicly crying to Paganini's musical execution. Although Rossini was wary to admit it, he eventually gave in to Paganini's musical symphony. Niccolo Paganini was a principal violin virtuoso and an Italian composer who had an apt ability in playing the violin. Some have said that Paganini was capable of playing up to 1,000 notes a minute with his hardly human characteristics. Although Paganini's personal physician, Francesco Bonatti, diagnosed him with tuberculosis and syphilis, Paganini's most likely benefactor of his flexible talents was Ehlers-Danlos syndrome. Ehlers-Danlos syndrome is a disorder in which it affects joints, blood vessel walls, and skin. This syndrome allowed Paganini to use his hands to a greater extent than that of the average man. And credits I give to Mrs. Ackerman for helping me with this video. Britannica.com, biologywise.com, and mayoclinic.org.